All right, you guys, we're going to continue our discussion about exponential functions, and we are going to solve exponential equations. So it says that equations that involve terms of the form a to the x, where a is greater than 0 and a does not equal 1, are referred to as exponential equations. Such equations can sometimes be solved by appropriately applying the laws of exponents and then the following property. So it says if a to the u equals a to the v, then u equals v. Okay, so when we are solving exponential equations, okay, one major way that these equations are going to differ and the way that we have normally seen equations is that our variables are going to be in the exponent. Okay, so the only way that we can solve for our exponents is if our bases are the same on both sides of our equation. This rule says that we can drop the bases and set the exponents equal to each other, which will allow us to solve for the variables. Okay, so notice in this rule you have one expression on the left-hand side, one expression on the right. The bases are the same, and if they're the same, you can drop the bases and set the exponents equal to each other. Okay, so let's try that. Let's do the next example. All right, so these say solve each exponential equation. So let's do A first. So we have 3x plus 1 equals 81. Okay. Now, by looking at this equation, I know it's an exponential equation without them telling me because I'm looking where my variable is. My variable is x, and x is in the exponent. Or one way I like to think about it, the variable is in the sky. It's in the superscript. Usually we're used to seeing our variables on the floor, as I call them. Like if you were to have 3x plus 2, everybody's on the floor. But now our exponents are in the sky, which means that we're going to have to use that rule. So that rule says if you have a to the u equals a to the v, then u equals v. So the way that that works, you have one expression on one side of each of the equal sign, which we do, but we need our bases to be the same on both sides. So the base on the left-hand side right now is a 3, and the base on the right-hand side is an 81. So first we have to see, is there a way that I can write both 3 and 81 in terms of the same base? Is there a number that I can raise to a power that will give me each of these? Well, 3 I'm going to keep the same, x plus 1. But let's see if I can break down 81. So I know 81 is 9 squared, and I know that 9 can be rewritten as 3 squared raised to the second. Okay, and by my laws of exponents, I know if I have a power raised to a power, I multiply them. So my right-hand side would be 3 to the 4th power. Okay, now I have the same base on both sides of my equation. So according to our rule, if the bases are the same, you can drop them and set your exponents equal to each other. So I'm going to have x plus 1 equals 4. Okay, now as you'll see, everybody's on the floor. Okay. Now that everybody's on the same level, you can solve like normal. Okay, so I'm going to subtract 1 from each side of my equation. And that's going to give me x equals 3. Okay, that's our answer for the first one. And we can always plug it in to check. We say 3. Let me change the color. All right, so if we want to check to see if we're right, we have 3 to the 3rd plus 1 equals 81, which is 3 to the 4th equals 81, and 3 to the 4th is 81. So that's true. Okay, so our first answer is x equals 3. Let's try our second example. It's in a different color. Oh, it's still A. It's supposed to be B. All right, so we have 4 to the 2x minus 1 equals 8x plus 3. Okay, so we want to identify where our variables are. Our variables are in the exponents. So we have an exponential equation. The only way we can solve for our variables is if we can somehow bring them to the floor or drop them out of the exponents. So we need our bases to be the same on both sides. So I'm looking at 4 and I'm looking at 8. So I want to see, is there a number that I can write raised to a power that will give me both 4 and 8? Well, yeah, we could use 2. 2 to the second power is 4. 2x minus 1. And 2 to the 3rd power is 8. Okay. Our laws of exponents say that if we have a power raised to a power, we multiply. So I'm going to distribute this 2 to the 2x and the 1, and this 3 to the x and the 3. So it's going to give me 2, 4x minus 2, 2, 3x plus 9. Okay. Now that my bases are the same on both sides of the equation, I can drop the bases and set their exponents equal to each other. So I have 4x minus 2 equals 3x plus 9. And then I can go ahead and solve for x. So I'm going to subtract 3x from both sides and add 2 to both sides. So that's going to give me x equals 11. Okay. And that's our answer. If you want to check to see if you're right, remember you can plug x equals 11 into our original equation, and you'll get the same answer on both sides. Cool. All right, let's try one more example. All right, it says solve e to the negative x squared equals e to the x raised to the second power times 1 over e to the third. Okay, so in order to use our rule, okay, our rule says a to the u equals a to the v, then u equals v. Notice that here you only have one expression on each side of the equation, but here we have two expressions on the right-hand side, and we have one on the left. So the first thing we're going to have to do is condense the expression on the right side of our equation before we even attempt to use this rule. Okay, so I have e to the negative x squared equals, all right, our laws of exponents say if you have a power raised to a power, you multiply. So that would be e to 2x times 1 over e to the third. All right, on the right-hand side, since I'm multiplying, I can put the first expression over 1 and multiply the numerators times the denominators. So that gives me e to negative x squared equals e 2x over e to the third. Okay. Our laws of exponents say if you have like bases and you're dividing, you subtract the powers. Okay. So I can say e to the negative x squared equals e 2x minus 3. Okay, now I have the same base on both sides of my equation, and I only have one expression on each side. So I can drop the bases and set their exponents equal to each other. So I have negative x squared equals 2x minus 3. Okay, this is a quadratic equation now because of the second power. Okay, so I'm going to put it in standard form. I'm going to move the x squared to the right-hand side to make it positive. Okay, now I need to solve this for x. So you could factor it, you could use the quadratic formula, whatever way you're most comfortable. I'm going to factor it. So I'm going to make 2 sets of parentheses. X is going to go in the front, 1 and 3. The 3 needs to be positive and the 1 needs to be negative. I'm going to set each one of those factors equal to 0. So x equals 1. And x equals negative 3. So for the second one, for all of these, I have two answers. X equals 1 and x equals negative 3. You're all done.